One topic that will come up over and over in chemistry, even as you move on, is net ionic equations. So when you're looking at net ionic equations, the theory behind it is if you mix solutions together, there are free ions that can form a compound. So for instance, if you have silver nitrate and it's aqueous, that means your compound was dissolved in water. So if you go and take a look at this dissolved in water, it would mean that you have silver ions floating around and nitrate ions floating around. So if you mix this with another solution with different ions, as all these ions are floating around, you can form another compound. And to know exactly what's reacting, you would do your net ionic equation. So here are some steps to follow for your net ionic. Step 1, get your balanced chemical equation. Step 2, write your total or your complete ionic equation. Step 3, cancel what's identical on your reactant and product side. That is your spectator ion or ions. There could be more than one. So those are present, they're around, they're just not participating in the reaction. What you're left with is your net ionic equation. So let's look at this first example. So you have silver nitrate in solution reacting with sodium sulfate in solution. So this is a double replacement reaction. So let's just start by writing out that reaction. And I needed a 2 there. Because it's a double replacement, your metals are swapping places. So Ag2SO4. When we take a look at your solubility table, you'll see that when sulfate reacts with silver, it is slightly soluble. So that's a solid. And then sodium nitrate, when they react together, we see that it's aqueous. So that's our beginning part. Don't forget to balance your equation. And that's your step 1, balanced chemical equation. Now we're going to write our total ionic. So this 2 in front means you have 2 silver and 2 nitrate ions. So I'll go ahead and write that. And the next one, that subscript on the sodium means there's 2 sodium ions. And then solids stay together. So Ag2SO4 does not break apart. And then lastly, that last compound, 2NaNO3, means there's 2 sodium ions and 2 nitrate ions. So just to point out here, again, this 2 means that there was 2 of each because this one stays together. This subscript means that there was 2 sodium. Solids, we do not break apart. And then same thing at the end here, 2 of each. Now, once you get to this point, just to point out a few things, your coefficients still matter. Your charge has to be shown. So if you wrote this without any charges, which is a common mistake in Chem 20, you want to make sure you go back and write in your charges. And actually I just noticed that should be -2. So now that we have that, you can see that you have 2 nitrate ions on each side and you have 2 sodium ions on each side. Those are your spectators. So if you're asked what are your spectators, it would be the sodium ion and the nitrate ion. That leaves you to your net ionic. So you write down exactly what you're left with. And we would have SO4 to negative to give you Ag2SO4. Often when I'm writing this, I get lazy and I stop writing the states on the ions, but anything that is an ion would have an AQ state. So this part here is your net ionic, exactly what's reacting. Now, all of your double replacement reactions that form a solid, this will happen. Now, some of your reactions, like this acid-base neutralization, something funny can occur, and this is just kind of like an exception that I'd like to show, just to know to look out for it. And that's when you have no solid forming. So when you react your HClO4 with strontium hydroxide, so plus SrOH2, so this is AQ, this is also AQ. It is a special double replacement. It's a neutralization reaction, which will form Sr bracket ClO4 2, and we'll take a look at the states, plus water, because it's a neutralization. So this is our liquid. Now from here, we'll also notice that we need to balance it. We also can notice that our state here, we have that ClO4, and strontium would fall under most because we don't see it here. So when these two react, this is going to be aqueous. You want to go ahead and balance this. So you would need a 2 in front of this HClO4. You'll need a 2 in front of the water. And I think the rest is balanced. Just double checking. Yes. So now we have our balanced chemical equation. We can go ahead and write out our net ionic or total ionic. So we have 2 hydrogen ions plus 2 of the ClO4 ion plus strontium 2 positive plus your hydroxide ion, but that subscript of 2 means there's 2 of them. On your product side, you have strontium 2 positive once again. You also have your ClO4, that subscript of 2 means there's 2 of them. And now with your water, pure liquids do not break apart. So you'd have 2H2O as a liquid. So now we have everything we need, and just pointing out, even though it's not a solid and it's a liquid, we still have it. What we're going to see as your ClO4 will cancel and strontium will cancel. And what you're left with is your 2 hydrogen ions reacting with your 2 hydroxide ions to give you 2 water molecules. So this is just a kind of not so much an exception, but usually we're looking for what's forming a solid. This is just pointing out you can also have pure liquids. So I hope you found this helpful. If you did, please subscribe. And if there's any other topic you would like a video on, please let me know in a comment. If you are in Chem 30 or taking calculus, I do have a website for each of those, and they are available, or the link is available for you in the description. Thanks for watching.